Okay, you've got a table. R of t is a differentiable function. It's the rate at which people leave a restaurant in people per hour. What's the approximation for the total number of people who have left the restaurant from t equals 0 to 10? And we're going to use a Riemann sum with 4 subintervals. So we're going to start from the first interval, which goes from 0 to 2 hours. So using a left-hand Riemann sum, the width of the rectangle is 2, and I want to use the y value on the left side, which would be 2. The next rectangle, width is still 2, and I'm going to use the left-hand y value, which is 4. Keep going. The next one, notice the width is 3, and I want to use the left y bound as 1. And the last one, width is 3, and I'm going to use 8. So if I do this, I get 4 plus 8 plus 3 plus 24. And it says that would give me 12, 15 plus 24, which is 39. Okay, next one. You've got a differentiable function again. It just means the slopes exist and it's continuous. We want to estimate of the integral using a midpoint Riemann sum. So remember, for a midpoint, you need a point in the middle. So in order to have a point in the middle, we have to actually go all the way from 1 to 9. So the width of the rectangle is 8, and we're going to use the y value in the middle, which gives me 3. And then same thing here. From 9 to 17, the width is 8, but the y value is 2. So notice you actually only use 2 rectangles for a midpoint. So this is 24 plus 16, which gives me 40. And then this one here, again, a table problem. We want to do a trapezoidal. So remember, area of a trapezoid is 1/2 the height times the sum of the 2 bases. We're going to do 3 trapezoids. So here's your first trapezoid. So it's 1/2. The height of the base is really the width, which is 3. And then your bases are your y values, which are 2 plus 1. There's your first trapezoid. Second one, 1/2. The height is 1, sum of the bases. The last trapezoid goes from 8 to 11, so height is 3, sum of your bases. And then if you do this, this is what, 9/2. This is 5/2. This is 21/2. So I get 35/2, which is the same as 17.5. Okay, and number 104 is asking about, let's say you have a twice differentiable function, so second derivative also exists, and it's increasing and concave down. So let's go ahead and draw a rough sketch. So it's an increasing curve and it's concave down on its entire domain. And we're going to use rectangles to come up with a left hand, a Riemann, and a trapezoidal to approximate the exact area. So which of these is an underestimate? So let's think about it. So if I do a right-hand rectangle, and no matter how big I make the rectangles, notice the right-hand rectangle will always go over the curve. So this is going to be an overestimate. Okay, let's take a look at a left-hand rectangle. So if I do a left-hand rectangle, so again, make the width the same. So I'm going to be here, here, here. So then notice the left hand is an underestimate. So this one is true. We want the underestimate. And the last one is a trapezoid. Okay, sometimes the trapezoid is a little bit hard to see. Okay, but you can picture it. So the trapezoidal is also an underestimate, but also sometimes it's hard to tell. Concave down graphs, trapezoidal is an underestimate. So both of these are underestimates, so it would be C. Okay, 107. I want to take this derivative. So remember, I'm taking the derivative both sides. This is an integral, so when I take the derivative of the right side, remember this 2x goes in for t. This is your second fundamental theorem. And then because the bound is not just x, we need to multiply by 2 again. So this is your general derivative, and let's plug in 1 for x. So I get 2 cubed, which is 8 times 2, which will give me 16. Okay, and the last one here, it gives me a couple values of definite integrals. I want to come up with this. So anytime we're adding and subtracting, one of the properties says I can split this up. So this is the same as this. Okay, this piece here, I don't have the integral from 1 to 8, But notice they give me an integral from 5 to 1 and 5 to 8. So if I integrate from 1 to 5 and add the integral from 5 to 8, that would give me the entire integral from 1 to 8 using the idea of addition. But 5 to 1 is 2. If I flip the bounds, this is actually the opposite. So this is -2. This we know is 3. So this integral right here is going to have a value of 1. Now this piece here, this we can just do geometrically, or we can go ahead and actually integrate it. This is 2x going from 1 to 8, which is 16 minus 1, which is 15. So the two added together, 15 plus 1 gives me 16. Oh, I'm sorry, when I plug in 1, this is 2. There we go. So it would be 14 plus 1, which is 15.